Hello everybody, I'm Benjamin Dumont. I will report the work conducted by Professor Bruno Basso and Ryan Nagelkirk. This work is entitled Using an Unmanned Aerial Vehicle, either called drone, to detect wheat response to nitrogen fertilizer and fungicides. So, first, what are the benefits of using UAV? UAV have to be seen as scouting tool. They will allow to assess the spatial variability, the one that we cannot see when we are within the field. If we look at the pictures, we can already see this is the field in the bottom left is a corn maize field, but you can already see the difference in the crop development. And if we perform a different fly over time during the season or over the season, UAV will allow us to assess the temporal variability. And with the appropriate data treatment, we will be able to detect nutrient and water deficiency, but also other stress that can impact the growth, like pests, weeds, or lodging. The objectives of this study were to use unmanned UAVs to evaluate wheat response to nitrogen fertilizer and fungicide. And to do so, we analyzed the spectral signature of wheat before and after the application of different treatments. So let's first describe the UAV and the devices. The lab has acquired a micro-drone MDR 4000. This drone has a spatial resolution of lower than 2 inches and a payload capacity of 3 pounds. The flying time is 25 minutes, and we have 3 batteries and 1 generator, so basically we can fly continuously over the field. We consider that we can cover 40 acres in 25 minutes. On this drone, there are different devices which will allow us to take pictures in the visible spectrum, but also in the thermal infrared spectrum. We have also a tetracam, which will allow to perform multispectral measurement to focus on specific band length and bandwidth to derive the most appropriate vegetation indices, and also a larger LiDAR scanner that will allow to measure crop height. Yeah, so this drone is, with all the sensor, $100,000. This is a huge amount, and so the lab acquired the Phantom 2 Vision Plus, which is only €1,000, to see what was the real added value of an expensive drone. And we can see on the picture, acquired with this drone, that a lot of information can already be derived using only the spectral and visible spectrum, the reflectance of the crop. So if we look, sorry for the guy that has the other screen, but if we looked at the upper right field, we can already see in a nitrogen trial differences in the green reflectance. If we go further in the season, see how the crop has grown as a different growth according to different nitrogen application. Let's focus now on the nitrogen response trial. Experiments were conducted on the MSU extension field, and we want to thank Mr. Martin Nagelkirk for the help during the field experiment. Here, on the May 30, 2040, we applied different nitrogen treatment, ranging from 0 to 120 per 40 kilo rate. Basically, in the visual spectrum, we can already see differences in the crop development. But look here, if we compute what is called the red vegetation index, the differences between 0 and 40, 0 and 80, 0 and 120 kilograms of nitrogen. And this is on May 30. If we go further in the season, the difference in basic pictures cannot really be seen, but using the red vegetation index, look what happened. The 0 is clearly missing nitrogen. Again, later in the season, big differences in the spectral response. And this can be derived using the drone that only cost $1,000. So Let's now focus on some quick fungicide efficacy trial. An experiment was designed to focus on 4 main fungus: Fusarium head blight, leaf rust, septoria leaf spot, and Stagnospora leaf blotch. You have the details of the field experiment. I will not describe them. I will either show you the 3 types of experiments that were conducted. The first experiment was a foliar fungicide efficacy. Here we apply different rate and at different moments of the year, different mixes of 7 fungicides, and we focus on comparing the response of the crop under control and under non-treated plots. The second experiment was to study the impact of the palisade growth regulator on lodging. And finally, the third treatment focused on detecting heat blight fungicide efficacy. So, the foliar fungicide efficacy. This is the main plot. We have a fungicide, infected, and a fungicide treatment and untreated plots. If we zoom out and if we go, at a higher scale, here is what happened when we derived the vegetation index. Unfortunately for you, I cannot show you because that year the control plots were not really infected. So we will keep the research going on this year and try to detect the added value on fungicide, but I can assure you there is one. We can go to the growth regulator trial. This is what we observed on lodging. There were no real differences under the control plot and under the plot where a growth regulator was applied. However, what we observed was a significant lodging in foliar fungicide when the foliar fungicide treatment was very high, far way too high than what you used to apply. Let's have a look at the heat blight specific trial. You have here an infected plant with heat blight. If we shoot, and if we fly over the field, and if we shoot at the zenith angle, can you see something? No, we cannot detect the heat, which is here, highlighted in red. And this is because if you fly over the field, and if you shoot at the zenith, it's only a point. You cannot detect the heat blight. However, if you shoot at 45 degrees, we can detect more clearly. And, there is something missing in the presentation. There should have 2 dots showing you, 2 dots showing you that if you shoot at 45 degrees, you can see the heat because it has a high response on the imagery. If you apply the proper data treatment, here it is. The heat blight can be detected. We will now work on differentiating the heat blight that are really infected from other artifact errors due to the data treatment. Is it all? Are there other advantages of using UAV? Of course there are. This is only exploratory research. We can go much further by using UAV. I will quickly show you some few examples. So this is a fly over a usual field, but what happened in the background of the field? And if we fly over there, we detect and we can quantify using UAV fly the high smothered areas. Another example is an image acquired on August 13 on a field where you can clearly see the impact of the crop interacting with the landscape, and we can clearly detect where water is missing. If water is missing, then the plant cannot appropriately extract nitrogen. There is a high deficit in chlorophyll, which you can see in the purple color, and so the plant is not in a well shape and the yield will be impacted. So, some conclusion. The image from UAV are able to show the spatial variability, but also the temporal variability across field, across treatment, across variety. But the vegetation indices needs to be converted in useful information to then apply the appropriate treatment on the appropriate zone of the field. Finally, I would like to thank Mr. Martin Nagelkirk for the support with the field experiment and also the Michigan Wheat Board for funding this research. Thank you.
Thank you, Ben.